Hi, everybody. My name is Sylvia. Today, I'm going to be talking about quadratic functions, specifically vertex of a parabola, axis of symmetry, minimum and maximum point, the general form of a function equation for a parabola, and the standard or vertex form of a parabola, and how to change from general form to vertex form. So first, just to go over a few basic things. So the vertex of a parabola is the turning point of the graph. For example, when you have a parabola facing upwards, the vertex is right here, and when the parabola is facing downwards, the vertex is up here. So next one is the axis of symmetry. That is the vertical or horizontal line that intersects the parabola at the vertex. So for example, if this is your parabola, here's the vertex, or it looks like this, or one of these here. Okay. So the axis of symmetry would go right down the middle, and it would basically cut the parabola in two equal halves. So these two would be vertical axes of symmetry, and these two would be horizontal axes of symmetry. Okay, so there are two kinds of two ways that you can write the equation for a parabola. The first one is called the general form. The general form of a quadratic function. And that is f of x equals ax squared plus bx plus c, where a, b, and c are real numbers. And a does not equal 0. So just a little bit more about this. In other words, if you have this parabola facing upwards like this, so in this case, when you have the function written down, the a would be greater than 0, which would mean that the a is positive. And so this one, I also want to add that we would have a minimum point. So in this case, again, the a would be greater than 0 or be positive, and this would be a minimum point. And then in this other situation, the a here would be less than 0. And so the a would be negative, and this would be considered a maximum point. Okay. So I'm going to do a couple of examples now regarding minimum and maximum points. Example 1, does f of x equals 4x squared plus x minus 1 have a minimum or maximum point? Well, first, it's very, very important that we identify what the A, B, and C are in this situation. So when I look at this, I notice something here. I notice that there's no number here. So when there's no number in front of the variable, it's assumed to be 1. And so in this case, the 4 would be the A, the 1 would be the B, and the -1 would be the C. So then looking at the A, which is 4, because the 4 is greater than 0, or is a positive number, the parabola has a minimum point. So would this be facing upwards or downwards? It would be facing upwards. So this is what the parabola would look like. So it would be a minimum point in this case. So all you have to do again is find the A and identify if it's greater or less than 0. Okay, example 2. Does f of x equals -x squared plus 4x plus 3 have a minimum or maximum point? So again, I want to take a look and see if there are any coefficients that are not obvious. So when I look at the -x squared, it is assumed that there is a 1 right there, just like with the other function. And so first identify the A, B, and C. The A is -1, B is 4, and C is 3. So since A is -1, and -1 is a number less than 0, or in other words, it's a negative number, the parabola opens downward, just like this. So if the parabola opens downward, that means that it has a maximum point. So it is considered a maximum point. Okay, so next I'm going to talk a little bit about the vertex form of a parabola, of a quadratic function. So vertex form, or it's also known as standard form, but I prefer to call it vertex form because you'll see why in a few minutes. I think it's more suitable for what the function offers. So the vertex form is f of x equals a times x minus h squared plus k. And so this form, it clearly shows the vertex of the parabola, which is h comma k. So as you can see, h is here, k is here. So the vertex will be identified as h comma k. So it's really easy to just look at it and say this is the vertex. But there's a very important point here, and this is something that students they get confused about often. I want to point out that this h, even though inside the parentheses it says minus h, making the h negative, when you write out the vertex or when you graph it, you want to make sure to change the negative to positive. So h would be positive k, and k would just be k. however k appears in the function. So the sign of h changes, but the sign of k does not change. So for example, if we have f of x equals 2 times x minus 3 squared plus 7. So here, what would the vertex be? I'll let you think about that for a second. And then what would the vertex be here? So for the first example, the vertex would be 3, 7. And the second example would be negative 3, 7. Yeah. And so the last thing that I'm going to go over is example 3. Rewrite f of x equals 13 plus x squared minus 6x into the form f of x equals a times x minus h squared plus k. So what form is given to us? Which form is this, general form or is it vertex form? So this is general form. That's given to us. And this is vertex form. So we want us to change to the other form. So the step 1 here, after I actually rewrite the function that's given to us, so step 1, I don't like the order here. I want to reorder these terms to make it look like the typical general form of the quadratic function. So I'm going to rearrange them like so. Okay. So now it's in the form ax squared plus bx plus c. Okay, so step 1 was to rearrange the terms. So step 2 is going to be to factor. So when you look at this, how can we factor this? At this point, if you want, you can pause the video and try to factor it and then come back. Okay, so when I look at this, I think, are there two numbers, do they exist that whose product is 13 and whose sum is -6? Do two numbers exist? No, they do not. So that means that we cannot factor this. You're welcome to use the quadratic formula to solve for x. That's one way you can do it, but I'm not going to cover that in this video. So the way I'm going to show you is that we could actually use the formula to find the vertex, to find the h or the x coordinate of the vertex. H equals negative b over 2a. So we can plug in these values and find h. So that will be step 3. Find h. Step 3. So so just plug in the plug in the b and the a. So we know that b is -6 and a is 1. So h equals -6 over 2 times 1. H equals -6 over 2. H equals -3. And finally, H equals 3. Okay, so H equals 3. So are we done yet? Not quite. So now we need to find the K, the second part of the vertex. So to find the K, all we need to do is plug in the 3 back into the function. Now I will rewrite the function that we were dealing with right here. So now we're going to do f of 3 and plug in 3 wherever we see x. So 3 squared minus 6 times 3 plus 13. So f of 3 equals 9 minus 18 plus 13. F of 3 equals negative 9 plus 13. And f of 3 equals 4. So what we did was for step 4, we just found the K. So that's what that is right there. We found the K, but we have H, we have K, and then we have the A is 1. So for the vertex form, and I will write that again one more time, the vertex form of a quadratic function is f of x equals a times x minus h squared plus k. And so just plug in whatever we know. F of x equals 1 times x minus 3 squared plus 4. And we can actually get rid of the 1. We really don't need it. So it'll be f of x equals x minus 3 squared plus 4. And that is our answer. Okay. So my method that I used here is to change from general form to standard form of a quadratic function for a parabola. I used the method of, like I said, trying to factor it. That didn't work, and then I found the vertex, and then I just plugged in the vertex into the vertex form. What I could have done is I could have taken the general form that's given to me, and instead of doing all this, I could have completed the square. So completing the square has its own different separate way of doing it. And that I'm not covering in this video either, but that is another option if some of you would prefer doing that. So you could complete the square and arrive at the vertex form rather than going through all this process. So that's just letting you know. I hope you enjoyed this video, and I hope that it was helpful to you.